Click on the Mimeo screen. This one. Click share.
Let's see what we'll get. We'll get a Mimeo screen. Well, are you seeing it? Are you seeing a screen on which we can show information?
Yes, I'm seeing a
Yes.
screen.
Yes? Okay, the Mimeo
Yeah.
screen. All right, let me write something down. Sorry?
You don't let them see you.
It seems no. Yeah. Okay. Well, do you wanna see me? I put some things here on the thing, not to be seen. Guess what? But we can take them off so we can be seen. Yay. Okay. Here we go. Do you see me now?
Yes.
Yeah.
Yeah. Very funny. Yeah. And I see David. Are you up? What the lala, man? Look at you. Okay, very funny. Okay, it's good you're up. It's good you are up. Okay, good. All right. So let's see. If I write here, whoops, just a second. Where is my? Let's put this down. The pen.
Back.
Okay. Yeah.
Yep.
If I write here, hello, you're
Alright.
good. You're seeing it.
Yes.
Okay.
Yeah.
So we're good with this. All right. So now, what would you like to work on? Do we give examples? What I suggest, let's do this, okay? My suggestion, you ask also, okay? We do have these two quizzes today, yeah? Did anybody take the quizzes yet?
I did.
No.
Okay. So what
I took one of them.
I took both.
Oh, David, then how much did you make? Do you know?
No, it didn't tell us.
No, it didn't tell us.
Okay. Then I hope you made 100, David, okay?
Yeah, me too.
Okay. All right. So for the students who didn't take them yet, we do have AKS 8, which is about the series, okay? How to calculate sum of series, geometric series. Does everybody understand what is a geometric series?
You just heard
Yes,
me.
no? Okay. Yeah. Okay, let's discuss the geometric series by going on the PDF with the review. It was a quiz, it was a PDF file which was uploaded maybe yesterday, yeah, with 3 videos from Mr. Jones. Did you look over it?
Yeah.
Okay, so I'm opening it now. Let me open it, find it wherever that is. Let me see. There is 3. So it should be here, right? So I'm opening it. Do you see it?
No.
No. Okay. So let me do then the next good thing. Let me copy a portion of it. I'm copying, so okay, so let's do like this. But you do have the PDF, yeah?
Yeah.
Yeah, so you have access to the PDF. So you can open your PDF on whatever, half of your screen there, because what I'm doing, I'm copying some problems from the PDF and we'll put them on the Mimeo, okay? To work them together. Yeah? Okay. So converges. Okay. So let's see this. You know what? Let's do exactly what we are working on today.
Hi, Miss Kindree.
Hello. Who are you exactly?
Chris.
Oh, it's Chris.
Chris Brown?
Chris Logan.
Chris Logan. My goodness gracious. Chris, you know what? I'm thinking so intensely of you that you got onto it, yeah? Cool. Very good. I love this. Okay. So let me do this. Let me copy and paste in the Mimeo video to work on something, all right? Just a second. I'm doing sums of this. Okay, let's do this. Okay, now here. Here, why do we have 2? Anyways, so yeah, let's paste. All right. So it's a kind of small, but we'll make it bigger like this.
She can't.
Okay. Tell me, please, all of you, if you see what I uploaded, what appeared on the page on Mimi video. Yeah. Do you see?
I have a question, Miss Kindree.
Yes.
I was on the My E-Class page and I was looking for the Unix 6C test, and when you said that it's been posted up and you could remake it, I went on there immediately, but it wouldn't let me do anything.
But just a second, did you click on the quizzes tab? It's under the quizzes tab.
Yeah, I clicked on the quizzes tab and I looked up the Unix 6C test, but it wouldn't let me open them or join them at all.
No, I was able to take them. So.
Hey, Mamma Mia's, turn your mics off if you are doing something else, or okay. So Chris Logan, just a second. So you said you went on into the quizzes and you clicked on Unit 6 test part 1, yeah?
Literally 2 minutes after you posted it, I went on there and looked at it, but it wouldn't let me take it. I can go look right now though. Let me see.
Yeah, let's try again because
I think the test ended at like 11 something. It had a time. It had a time on there, 11.
It's saying I can take it now. Actually.
Yeah. Maybe you went in earlier than or before it was visible, active for the students. Okay.
Yeah, probably. I started.
Yeah. Okay, just go slowly on that. Take your time. It's okay. If you have any questions about that, that's a different issue.
Yes, ma'am.
We can tackle them. Okay. So does everybody see what I uploaded here? What I copied and pasted to problem 17, 18, 19, 20, 21, 22? Do you see them?
No.
So how am I doing this?
I think it's on the other screen.
What screen?
You had two Mimeo screens.
To put it here?
Yeah.
Just a second. What is that?
I don't know.
Well, it's my phone.
No idea.
What is that?
Hello? Hello? Yes? From whom?
Thank you.
I'm good, but I'm doing something right now. If you could call later in the next 2 hours, fine. Okay. Seniors benefits. Do you see it here?
Yes. Yes.
Okay. Okay. So just a second. Let me maybe just bye this screen. So say current things. Okay. No. So you're good with this, yeah? All right. So let's see what the questions are here. The questions are, what is this? Okay, the questions are evaluate each geometric series described, correct? Do you agree?
Yes.
Okay, how do we do this? What do you see?
You gotta find the rule, I guess.
The rule?
Or like how to solve it, right?
Okay, but what are we looking at? We are looking at geometric series. Can we describe this geometric series have the same thing in common? They show us n equals 9, n equals 8, n equals 8, n equals 6. The summation notation, this sigma symbol, k equals 1 to 8, ki equals 1 to 7. So is it a finite geometric series or an infinite geometric series?
Are there two different formulas for finite and infinite?
Exactly.
Infinite.
Exactly. So what are we dealing with here? Finite or infinite?
Infinite.
9 terms, is it infinite?
Oh.
Okay,
so it's
so
finite.
let's do this. So please say anything you think. Everything is good. We just work together, okay? So let's do this here, okay? Let's go a little back in time. What's a series? A series is an addition, okay? Addition, I'm adding terms which are actually forming a geometric sequence, all right? So when I look here at 1, 4, 16, Okay? You see what I'm doing? I'm writing them as a list, correct?
Yeah.
Agree?
Yeah.
How many did I write so far?
4.
4. I go all the way to 9, yeah? So this will be like your A1, the first term, all the way to A9, all right? That will need to calculate to multiply bit by bit by 4, yeah? So this is your A1, A2, A3, A sub 1, A sub 2, A sub 3, A sub 4, okay? Up to A sub 9. So once I'm stopping here at A sub 9, that's a finite geometric sequence if it's like this with commas between the numbers, series if it's with addition between the numbers with the symbol plus, yeah, operator. Got it?
Yeah.
Everybody you are clear on it, yeah? So everything here is finite, okay? I have n equals 8, n equals 6, all right. So we are dealing with finite. Pay attention how I'm thinking these problems. So you will be given, calculate the sum of these whatever series, yeah? And you look at it and you see n equals the number. Okay, if n equals the number, look what I'm writing here. I'm writing the formula. So what is the formula for the sum of a finite series? N for n terms, n. I need n, not infinity, okay? So you have your notes. Look at the formula and tell me the formula, okay? What am I writing? I forgot it.
Since they all multiply by 4.
Mamma mia, I need the formula. This is the formula in general. I don't know the formula. Once once we all write the formula, we read the formula, and then we go back and identify each element in the formula. Tell me what formula am I using for this problem? Am I using this one? Let me jog your mind. Am I using this? Wow. Does this have anything to do with what we're doing now?
No.
Okay, then
No.
tell me the formula for our lesson today.
Is it you looking for the finite formula or the infinite formula?
We are in the finite scenario.
S and equals A. 1.
Whoa. Hey, A times, open parenthesis, because this is what you have to put in the calculator, right? So don't tell me A1 fraction line. Yeah, fraction line. And then what are we writing on the numerator?
1 minus. What is it? I can't see. Is it 3? No.
It's R.
R
N to what?
Or N.
The power of n, exponent n, close parentheses, okay. Over what? Divided by?
1 minus R.
Okay, very good. Now, okay, whoa, this is the formula I need to use in this problem, yeah? Interesting enough. So we need A, we need R, and we need N, correct?
Yes.
So this applies for all these 6 examples up here, okay? It's no other way to go unless we identify A, R, and N. Otherwise, I cannot plug in the formula, okay? It's a formula which needs these letters substituted by the numbers, okay? The corresponding numbers for each exercise, yeah?
Yeah.
So this is exactly what we'll have to do on the quiz, correct? So now, let's, so we have this. So we have this as a generic understanding, all right? Now with this put here, let's go for each example. So let's see for 17. We do 17 and we do maybe which one you want, 19, 18, and 20, and then we do one in sigma notation, all right? And then we go to the finite, and then we go to statistics, and then you make 100 on both quizzes. Does that sound like a plan, a game plan?
Yeah.
Okay. It's easy breezy once you are confident what to plug in the formula, all right? Okay, so for number 17, what is my A? A equals, A is what? What is the first term in the series or the sequence? So this A sub 1 or A by itself is actually the first term here, yeah? The very first term. So when the series is given to you like this as a sum term by term, yeah? You are just reading the first term, yeah? So the first term is, what am I writing?
-3.
We are at
here.
17.
So 1.
Uh-huh.
Is one.
Yeah. Yeah. Now, how do we calculate the common ratio? Do you know how to do it?
No.
You divide the second term by the first term.
Perfect. So the formula here, if I'm to write the formula here, I'm writing it here, A2 divided by A1. And I can check myself also, must be equal to A3 divided by A2, yeah, and so on, yeah. So the second divided by the first, the third by the second, okay. All right, so A4 divided by A3. So you will be given geometric sequences, so that will be okay. So A2 divided by A1, 1 on the third, and this is 4 divided by 1, yeah? So
Yeah.
I read here 4. Okay, so the common ratio is actually the number which you multiply the first term by to get the second term, yeah? So you do 1 times the ratio. A1 times R gives you A2, yeah? So A1 times R equals A2. So R, how do you find the R? You see how you divide by A1 on both sides? And that's how you
So
get
A2
answer.
divided by A1 is R.
Yes. So this is what you need to apply to find the R at any time. You see why? Because you go from the first term, the pattern. The pattern starts from the first term, okay? I'm multiplying the first term by 4. I get 4. Second term, multiplied by 4. I get 16. 16 times 4, I get 64. So how do I get back to this R, to this common ratio? I check it algebraically by what I wrote here, exactly this equation. If you also can figure it out just by looking at them, okay? With your eagle eye and with your, good mind, you say this, 1 times how much equals 4? 1 times 4, all right? Go a little and play with the 18. 18. Negative 4 times how much is 16? Try. Negative 4 times how much is 16?
-4.
You see? So that's your R. Because if you put now R equals A2, which is 16, divided by -4, that's exactly your answer here, -4, yeah?
-4.
Mm-hmm.
And then
Now,
-64 divided by 16 is also -4.
yeah, exactly. Yeah, so they repeat and they are correct. Yeah. What do you do for 19? What would be the ratio here? -2 times how much is -10? Because you see, I
5.
always multiply. Multiply like this. See, multiply by 5. Multiply by 5. That's
Yeah,
the
multiply by 5.
yeah. If you don't see it like this, if you don't see it in your mind, mental math, you need to write this. You need to write this here and find your ratio. Okay. Okay. When there are numbers bigger than 1, it's easier. When you have to multiply by a fraction, maybe, when you go down, it's a little trickier, but it's doable, okay, by the formula. Okay, and now what's the n? N equals?
And is 9.
N is 9 in this problem,
N is
17,
9.
okay? Okay, so let's plug in the formula and let's use our calculators and let's see what we get, okay? You did it already?
So A 1 minus R.
Where did you get the? I'm confused.
Okay, with what part?
In the
Where's the 9 coming from?
From the number.
9 is
from,
N.
From the number of terms, n here.
N comes with the equation, right?
Yes.
All right.
It's right here, yeah.
All right.
The
I got
example is the exponent. Mm-hmm. Yeah. Let me try to erase this mushy 9 from here. I'm waiting for you to calculate, okay? Take a few seconds and calculate. Mm-hmm. Yeah, let's see what we get, all of us. You see, you need calculators now. You either have one on the cell phone, on the computer, one in your hand. I don't really know what you're working with.
Divided by 1 minus 4.
What did you get?
87,381.
Yeah, exactly. Yeah. Naija?
That's it.
Yes.
Mm-hmm. Okay. So everybody got this, yeah? Okay. Let's see. What if we have a ratio which is negative? Let's see how we will put that in the formula, okay? Because this minus here doesn't have anything to do with this r. If r is negative, we'll need to put it by itself in parentheses, okay, to isolate it from this minus, and then raise to the power of n. So let's do number 20, yeah? We'll do 20. I'm erasing here 17. Or yeah, I'm erasing 17. You calculate. You start working on 20 and tell me what to write, yeah? Because now, as I'm looking, I will just plug in the formula, all right? You learn the lesson. Now we're just practicing. So for 20, I know I need to calculate S6, correct? Chris Logan. Chris?
Yes.
You see S subindex 6. This is your N from here, from the left side, correct?
Yes.
Okay. Now let's draw the fraction line.
Mm-hmm.
And let's help each other. You tell me A1.
You said from the left side or the right side? Oh yeah, that's from the right side from my point. But A1 is -2.
Yes, this is -2 on number 20. Very good. Open parentheses. 1 minus.
1 minus r over.
The r is. How do I get from 2 to 4?
You add 2.
-2
times how much is plus 4?
2. 1. Yeah, 2.
-2.
-2.
-2.
Mamma mia's -2. So you see what I do now is the -2? I have to put it in parentheses because this negative will multiply by itself as many times as the exponent is here, correct?
Yeah.
Yes.
So if you don't put it in parentheses, these signs will get messed up, all right?
It get confusing. Okay, I got you.
So what do we do now at the denominator? What am I writing here?
1 minus -2.
1 minus -2, like this.
Thanks, Chris.
You know, some calculators are smart. You don't really need to put all these parentheses, but for safety, just put them, because I don't know what you're working with. So that's where you can get messed up really here, because you see it's pretty easy, self-explanatory what you put in. Okay, now you work, I work. Let's see what we get. Okay.
Yeah.
Yeah. Pay attention to the negatives and that's.
All right, let's see.
Jada Nichols, are you here with us?
Yes, I'm here.
Are you following? Is it? I mean, the pace. Is it good for you?
Yes.
Okay.
Yes, I think I understand it.
Okay, so ask Tommy, or ask exactly what you don't understand. Okay. Are you putting in the calculator now S6? We need to calculate the sum for these 6 terms. Don't let me be by myself here.
Okay, so when I put it in the calculator, I put it in exactly like that.
Exactly like that. Yeah.
Okay.
If it doesn't look like that, of course you'll get a different answer. Okay. If you wrote something wrong, that's a different issue. Okay. That's another discussion.
Miss Kindree?
Yes.
So the work that we're doing right now, is that supposed to help us for AKS 8 quiz or AKS 27 quiz?
Right now we are on AKS
8.
AKS 8. It's the lesson of
27
Monday.
is about the surveys and the data collection, isn't it?
Yes. Yeah. How much did you get? Did anybody press on enter yet?
I don't know if this is right.
Okay. What did you get?
42.
Yes, I got 42 also. Maybe both of us are right or wrong. Anybody else who can pledge for 42 or not?
I got 42.
I second that.
Oh, wow. Come on. How many?
I got 42.
Do it.
Students.
Y'all got it too?
Okay. Everybody got 42. Okay. Very cool. Okay, so we're good. So with finite series, we are really getting there, I'm pretty sure. So you are good with the formula. You just go with it, plug it in, and so on and so forth. Oh, let's do a summation. Let's do an example for a summation, okay? Because you'll have one like this, sum of terms, and the other one with summation summation notation. So let's do one in summation notation. Let's do 21, yeah? 21. Okay. Just a second. Okay, 21. All right. So I'm by buying all this nonsense here. Okay, we are on 21. Just a second. Okay, so 21, everybody. You good?
Yes.
Okay, so what I'm writing for 21, it's for, or you know what, let me just erase this. So the summation notation, I'm writing something for any problem in sigma notation, okay? So this is our like our starting point, our guiding point, reference point, okay, for this type of problems with sigma notation, okay? So sigma, I'm writing it here, sigma. Oh, sorry. I don't know. I'm not making it happen. Just a sigma, a nicer sigma.
Are you going to teach us AKS 27?
I'm not teaching it. I'm practicing it with you. I mean, we'll go over it, definitions, whatever you need. We do some examples, and yeah. We'll do it. We'll do it.
So yes.
Yes. Okay. So pay attention a little. Sigma here, it starts from k equals 1. It goes to whatever number n, to whatever number of terms, okay? Number of terms. The very first thing you have after this sigma notation is a times, and in parentheses or no parentheses. If it's in parentheses, you see it's a negative number in parentheses here, -6. If it's not parentheses, it will be a positive number. What are you having in the parentheses? The common ratio to the power of k minus 1. All the problems will be to the power of k minus 1, okay? In sigma notation like this. So now when I have this, what am I reading? I'm reading the number of terms. This is the n from here, okay? Number of terms. In the finite geometric sequences, n equals how much you see, how much is given to you here, or it's given up here, yeah? Will be 8 in our example 21. So now let's read exactly what do we have here. We have n equals 8, correct? Then we start with the first term, k equals 1. Now a in our example here is -3. So here is your first term, a1, first term, yeah? And this will be the common ratio, yeah? Common ratio. So I'm giving you this so you know how to read the elements which you need to put in the what? In the formula, yeah? Which you need to plug in the formula. That's all that I'm doing here, okay? So now when I'm doing Sn for a finite geometric series, it's the same formula here on the left, okay? So now, how do I make the connection between A1, R, and then in sigma notation? Okay, this is N, yeah? This is A1 or A, and this is your R. And we're done. Now we just plug in, correct? You see how fast I'm doing it once I'm identifying the elements of the formula, correct? Okay, so now Sn, A1, what am I writing? -3, yeah? That's it. I have A1 here, it's -3 here, correct? Open parentheses. The formula says open parentheses, 1 minus. What's the R? It's given to you in sigma notation. You just need to know where to look. You just must know where to look, yeah? It's the 3. To what power? Chris, what power?
8.
8.
Is it
8. 8. Yeah, correct. And over what? 1 minus the 3. Yeah, 3. The ratio is positive 3. Okay. So now again, calculator, and let's see what we get. So this should be a 10-minute quiz, all right? Just plug in. Don't overthink it too much. Get, however, you know, afraid of this science or whatever you have to plug in, yeah? Just be confident. What you see is what you'll get. What did you get for this one, please?
I got
Negative 9,008.
40.
How much? How much?
I got minus 9840.
Yes, exact. Perfect. Okay. Does everybody feel you are good on this? We can move on, yeah? That's all what it is to it, all right? And for the infinite geometric series, the formula is much simpler because you don't have the n. We'll do an example there too, or you know what? Let's no. I need to show you from there. I need to copy and paste because for the infinite geometric series, we need to have the ratio is actually between -1 and 1, yeah. So that's what we need to do. Okay, so I will insert, just bear a little with me to insert here a new page. Okay, I'm copying now. I need to copy some pages. Just give me a second here. So from the PDF, I'm copying from the PDF the problems 39, 40, 41, and 42, just for you to see more examples. Wait, what is this here? I don't like that. Well, 40 doesn't really work for us, but so copy. Okay, here. Okay. Okay, you see them? Yeah?
Yes.
You see them, yeah? Okay. If you see them, we're good to go. We're good to go. Okay. So let's see what we are reading here now. So you'll be asked to calculate the sum of this series, okay? Of series 39, all right? So what am I reading at 39? I start reading for 39, okay? Let's identify, is it finite? Is it finite? Or infinite? Or infinite? So does it ever stop? Do I see an n equals to something?
No.
No.
No. So n is actually infinity. So this is infinite, okay? Okay, if it's infinite, what is the formula for infinite series? For the sum of an infinite geometric series. So see here, you can have this symbol or nothing. You see, S of an infinite series is S by itself and is equal to what? I forgot.
The first term divided by 1 minus 3. I mean 1 minus r.
Done. Okay, so this is it, all right? So put this in a box, and this is what you'll be using on the quiz, okay? Now, all right, let's calculate a few. So for 39, we go back to 39, yeah? What am I calculating? S, I'm doing the fraction line, writing the fraction line. The first term is over 1 minus, what is the ratio here? The ratio here, the best is to calculate it by doing R equals A2 over A1. Put it in the calculator and you'll get an in fraction form. So negative divided by negative is plus, I mean, I would put here what? Negative 5 over 3 divided by negative 5, correct? So by the negative 5 over 3 times, you know, the reciprocal of 5, which is 5 over 1 times 1 over 5. And actually, this is 1 over 3 in the end, yeah? 1 over 3. This is the one here. If you are, you know, fast with your eyes here, you see that from 5 I go to 5 over 3. So what happens? I divide it by 3. When you divide by 3, you actually multiply by 1 over 3. That's how the the infinite geometric sequences will converge, will go to a certain numbers. If you see here, for example, here, this is an infinite geometric series. We don't have an n, which is a number, will be infinity. But here the ratio between being the ratio is 4. So actually the sum of this infinite geometric series is infinity because it doesn't stop anywhere, okay? It just keeps going up, the numbers. You understand the difference?
Okay.
You understand the difference
It makes
here?
more sense now.
Yeah, yeah. So now what I have here, what R do I have here? I have 1 over 3, yeah? Okay. So it's again a matter of calculator, or if you want to play with it a little, you write -5 times, and me, I'm doing this in my head, and 1 minus 1/3 is 2/3. I flip it and I get this. And it's still a mushy number. I mean, I'm saying 5 and 2 don't simplify or reduce. So I'm getting -15 over 2. And -15 over 2 equals -7.5. Did anybody plug this in the calculator and got -7.5 or another answer?
Yeah.
So it's -7.5? Okay,
Yep.
so that's our answer, all right? With big negative here, okay? Don't lose the signs, because I don't know how the choices are, but if they give you plus and minus the same answer, you need to make sure you're correct, okay? Just maybe double check it, do it twice, or make sure you see once you write in the formula correct, the -5, the 1, the minus, and the 1 over 3 here, yeah? Everything should be all right. Okay, let's do, so 40 is infinity because the R is greater than 1. You notice from the notes that the common ratio must be in absolute value, be less than 1. So it must be a number between -1 and 0. Otherwise, the sum will go either to positive infinity or to negative infinity, depending on how how the ratio is, yeah? The common ratio. Let's look at 41. 41. What do you see about the summation here? So the summation, what am I reading? N equals 1 to infinity. The first term is?
0.6.
0.6. So what do I put in the formula? 0.6, correct?
Mm.
What is the ratio?
0.8, -0.8.
Negative 0.8. I need to put negative, and I'm putting nada. We need that negative there. Without the negative, we're not making it. Come on. Okay. Yeah, really. Okay. Now, what did we get? Because here, with this 0.6 and would be what? 0.6. Actually, it's 0.6 divided by, you agree it's 1.8, because actually minus and minus bye-bye, gives me plus a 1.1 plus 0.8 is 1.8. And this is now what? Times 10 times 10. So 6 over 18 is 1 over 3. Did we get 1 over 3 or 0.33? I'm plugging in now as it was, 0.6 divided by, I have that calculator with the fraction. Yeah, so fraction line, so I'm creating my fraction. And 1 minus 0.8. And did you get 0.33?
Yes.
Yeah. So this is it. This is it. Do you want to do 42 also, or we get on the other on statistics a little?
I'm good.
You're good with this?
Yes.
Okay. Okay. Then now let's see a little. What can we put from the Jada? Jada. Jada, we lost Jada Nichols.
No, I'm here. Can you hear me?
Yeah. I hear you. You know, you mentioned about that triangle series that you wanted to see how it works. So actually that problem, so Jada was asking about this thing, if I remember correctly. Well, okay. That was on Monday. You remember that problem, and you are having this triangle here. it was an equilateral triangle, and this another equilateral triangle, and another one, and they were like 5 in total. Okay, I get to do here like 4, and they were these were black. Remember the task which you had to turn in?
Yes.
Yes.
Okay, so they, as you have the problem here, they gave you the area here, the area of the first triangle. Jada was asking me how we do this, yeah? So it's 1, correct? That was given to you, 1. And then they said to add the sum of the first 5 triangles which form above here, above the first black one, you know? So it was this of area 1. And now when you go, have the distance here, have the distance between the very top here, this is, oh, what am I, no, I showed a little, not good here. Yes. So what I wanted to show you here, how you think about this problem, it's that it's actually divided by 2 here. So here you have half of each side, yeah? So here is 1/2 and 1/2 here. All this side here is half, okay? So when you create this triangle here, and they say area 1, then here, this part here is equal to this part. So now I have here 1/2 and 1/2. So actually this triangle, the proportionality, the ratio between this triangle and this triangle is 1/2. So being 1/2, you have area. Area by definition is 1/2 base times height, yeah? So being 1/2, the base is half of the initial one and half of the initial one. So actually you'll have 1/2 times, so b times h here is 1. And here now you have 1/2 times 1/2. So here, oh, I'm writing ahead of. So here the ratio, the common ratio, how I get to from the bigger triangle to the smaller triangle is 1/4. So what I'm trying to share with you here is this. Just a second. I'm cleaning up a little here to show you how this becomes. Just a second. Just a second. Okay. Well, okay, we can leave it like that. So what I have here, this area, the initial area was 1, yeah? And this is actually 1/2 times what I have here, the first, the b times the h, yeah? They don't give us the b and the h. But now what I have here, the second, so this is your a1 is 1, h2. A2 is what? Is this 1/2 times b over 2 times h/2, okay? So what this becomes now becomes 1/2 times b times h times this 1/4 from here, 1/4 from here, okay? So what I'm having 1 times 1/4. This is my common ratio between each triangle going up, because I'm going halfway, half distance, you see, from, if I'm to do it again, oh my gosh, that's not an equilateral at all. That's interesting. No more equilateral. So this is, you see how I'm dividing it in half, yeah? So this gives me the very first big one, yeah? And now when I'm dividing again in half, I get the next one. So this is again in half, I get the third one, all right? So it will be always divided in half the distance here, but the area of the triangle will actually go 4 times smaller. The area will become 4 times smaller, okay? So when I'm calculating the sum of the first 5 triangles, starting from 1, 1, and the ratio is 1/4, and the n is 5, what do I have? I have, let's write it, a times 1 minus r to the and power over 1 minus r, okay? So I'm calculating actually 1 times 1 minus 1 over 4 to the 5th power here. This 1 over 4 in parentheses to the 5th power, and 1 minus 1 over 4. That's what I'm doing here. And I'm getting, if we plug this now in the calculator, we'll get an answer. Jada, did you follow? Does it make sense?
Yes, but
Yeah,
okay.
a little, yeah, because you know, linearly wise, when I go on one side, I divide by 2. But when I calculate the area, 2 sides I have to divide by 2. So that's why here the B and the H divided by 2 each of them gives me this new factor of 1 over 4. That's the only, I would say, glitch in this problem, you see. It's not a simple division by 2, it's a division by 4 because of the area. They ask for the area, not the side, the sum of the sides, you see. So I'm just plugging in this thing to finish it, yeah. So I'm just see 1 times. I don't need the 1. 1 is 1, okay? So I'm plugging in 1 minus. So at the top, 1 minus. 1 minus. And now I mean 1 over 4. 1 over 4, instead of creating another fraction, you can write it as what? 0.25, yeah? 0.25 to the power of 5. Go under, below the fraction line, and you have 1 minus 1 over 4. 1 minus 25 cents. How much is a dollar minus 25 cents? Somebody. How many cents?
75.
Yeah, so that's it. So you see, you can play a little with these fractions. It's not so like, wow, okay, what am I doing next, you know? Just a second. In all this glitch, I got a syntax error. What the lala did I do here? 1 minus, maybe this minus. They don't like this minus. Yeah. Instead of minus, I put the negative symbol, you know, the negative, like a negative number. So yeah, pay attention what you put in. If it's error, just do it again. See, man, I made a mistake somewhere, yeah? So
Miss Kindree, I saw that I got 1.
1 point?
Just 1.
No, it's 1.33, 125. Can't be just 1. You have 1 minus, so the numerator is 1 minus 0.25 to the 5th power, yeah?
Okay, I think I found where I messed up.
Uh-huh. So you got now the answer?
I'm looking now.
Yeah. Look, because it cannot be 1. I mean, the numbers, these decimals, that don't go back to 1, that's for sure.
Okay,
I mean,
I got 1.333125.
That's it. That's it. Very good. Okay, so it's possible. It's just this being a word problem. It's a matter of understanding what is the first term. Oh, the first term is the area of the biggest triangle, and then how do I get to create the terms in the series? So what am I adding? 1 plus 1 over 4 plus. Tell me the next one. 1 over 4 divided by 4. How much is it? 1 over 4 divided by 4 will be 4 times less, yeah? So like this, you see how it goes smaller?
16.
Yeah, and now how much is 64 times 4? I don't know. 16, oh, it's 16 times 16 would be 256? No, yeah. Okay, and you see now, these are only 5 terms. You can really put them in the calculator right now and get that 1.33 and so on and so forth, yeah? But if they ask you how much is the sum of these 20 triangles forming, you kind of want to use the formula, yeah? Okay. We're good?
Mm-hmm.
Yes.
What do you suggest to do about the statistics? What would be your questions, or how is the best thing to do that? Do you have more your examples? You wanna those more detailed, or what?
This is good.
What is good? Yeah, but this is done. What are we putting on for statistics?
So ask them what they want
What would you like to see in statistics? What file or what kind of problems? Let's go over some of the problems. Which what would you like to discuss? Tell me what to bring in. Bring in. New page. Because you know the answers, I mean the questions, the questions will be very specific, very easy. It will be presented to your study, and how is it realized? Yeah, how can you do this study? By observation, experiment, or survey. So that's all what it is about. So you need to know how you differentiate this. All right, 3 types of making a study, of making a research, actually. Let's see. I'm pretty sure we have some good stuff here. We'll just copy and paste something in the, yeah, we can do that. What do? I copy and paste? Something like that.
I would just copy this in one page and then copy each one of these and then talk about why they are what they are.
Yeah. Okay, we'll do a little copy and paste here. So we do the very first day, Tuesday, okay? Tuesday about surveys, observational study, and experimental study or experimental study.
So that's just the definitions.
Yeah. Okay. We will go over the definitions. All right. You agree? Here we go. So, do you see the definitions here? Tell me, do you see them?
Yes.
Okay. So take a minute, look over this. I'm leaving them here and I'm uploading one more thing here, okay? I mean, I'm uploading an example of this. Let's see. We do like this? No. Okay, Mama Mias. So what's going on with this example? Can we see how many are present or
Yeah, click.
here or where?
Click right there.
Because I'm seeing only that. Okay. Mama Mias, how many are you present here? 6 students? 4. 4
Hi.
or 5. Jada, Sahar, good morning or good afternoon, Sahar.
Hi, Miss Kindree.
Hey, and Vanessa, hi. Good,
Hi, Miss
good to hear your voices, Mama Mia. I see you, Mama Mia. Look, there are some notes, but yeah. Well, okay. People were here. Yeah, you will be using. Okay. So how do we keep up with the chat and that and the other? So you do see the screen, yeah? Okay.
Yeah.
So just a second. Where were we here with that thing? Okay. So what about this problem? What are we reading and what do we think it is? Because you need to read the problem and get those keywords out of it and what's the difference between that and the other. I mean, the type of studies, okay? So Sahar.
Yes,
Come
Miss
on with your
Kindree.
beautiful voice, read the problem for us to figure out what's happening here. Pretty please. Do you see it, the problem? Sahar.
Uh-oh.
Uh-oh. Who is left? Okay, nobody. Okay. No. Let's see. So, John.
Hi.
Hi, how are you?
I'm here.
Do you see the problem? Would you read it for us?
Okay.
Yeah, let's see what's going on. Oh, but why don't I hear you? Are they on mute or something? No. But
Yeah, they
oh,
have to
wonderful!
unmute.
Oh my gosh! But I was hearing them, but then see,
They
I
have
click on.
they have to unmute themselves.
Can you unmute yourselves? Unmute
Like,
yourselves. Yeah.
I
So I
don't
have John active. Sahar.
know what just happened. It like just kicked me out right before I read. All right. You
Yeah, I
ready?
am.
Oh shoot. Why are students missing so much school in the district? A district administrator selects 300 student names at random from the enrollment list and sends a letter to each student's home. The letter includes a page to be returned to their school signed by a parent or guardian. The page asks, how many days has your student missed school this year? And what are the reasons for missing school on those days?
Mm-hmm. So
That's it.
what is happening here?
I mean, looks like a survey.
It looks like a survey. So do you have these definitions written somewhere? Do you have
I
a
don't
guide
actually.
to
I need to.
read them? Write them. Take a minute and write them down, or Google them or something like that, because you need to have exactly in mind. So a survey is a set of questions, okay, given to people to seek their responses. So you can go
Okay.
in a mall, in the Georgia Mall or wherever you want to go in our high school, all right? If we were actually in school now, we would have had a project. You would have had to do a study and use your own method of accomplishing it. So you could have done it by using a survey method, okay? So you would have stayed on the hallways of the high school and at random ask questions to whatever students you would like, And of course, these are different way of do the study, but the survey, you just ask the questions as the people come by, okay? So you could do it like this, or as it's done in this problem, you send the questionnaire. It's still a questionnaire to be answered to, yeah? It's still a survey. So you answer verbally or in writing. This is a survey, okay?
Okay.
Yeah, it makes pretty good
I'm still
sense.
writing it down.
Yes, write it down. In the meantime, I'm doing something else here. You're fine. Keep writing, it's fine. Yeah, just to make sure you have this and you feel good about them, And realize the keywords in the problem. The keywords will always, there will be keywords which will send you to what they are: survey, observation, or experiment. And we'll see in the next example here. Okay, I'm copying
All
this.
right. I got it.
Okay. So now, for example, this here. Whoa. Why is it so big? Okay. Trying to make it smaller, not bigger. Okay. What is this?
Use the other end.
The what?
The other end.
Yeah, but it's too big. It's too crazy. No, like that. Yeah. It went out of the reach. Gracias. So let me a little, I want it smaller. It's okay. So we have another problem now, another example, okay? So let's read this one and let's see what happens here, okay? All right. So John, you're still with us, yeah?
Yeah.
John, and we have Jada and Sahar and Vanessa. Okay. So, John, would you please read the next problem and see what's happening here?
All right. What type of sweetener do flies prefer? A scientist puts the same amount of each sweetener into different bowls of water and counts the number of flies that drink from each bowl in 4 hours.
Mm-hmm.
Looks like an experimental study.
Looks like. But do we have here what's what's the key aspect of an experimental study? The key aspect.
Directly influenced.
Yeah, but directly influenced. But this is actually just putting different kinds of sugar. It doesn't have the group of reference called the control group. Okay, so this is actually not changing anything, just observing who's liking what kind of sugar. Okay, go with this a little step further, like imagining in the high school, you want to see what kind of drinks the students drink most during the day out of those automated or automatic machines. How do you call them? Yeah. So you remember how they are replenished during during lunchtime some days. So let's say in the morning they are filled up with Coke, Sprite, and water, and by the end of the day you just notice how many are left, and so that's the preference of the students. But you didn't tell anybody, hey man, get the water, or hey, get the Coke because it keeps you awake longer, or get the water because it's healthier, or you didn't influence in any way what happened that day. Yeah, everybody did what they wanted, so the flies are just going there, and I don't know by what criteria they would drink out of those bowls. Maybe they have a sense of smell or whatever they feel like, but that's what's going on. Yeah, so nobody's influencing anybody in an observational study. I just look and observe. Yeah, and here I just put those 4, or how many are here? 4 different, no, how many? Well, into different bowls. They don't say how many. Puts the same amount of each sweetener. What type of sweetener? They don't say how many types. Okay, but I just notice what's going on. So I don't have a reference group to see. Oh, okay, that made better than the other one. I'm not comparing anything. See, I'm just collecting data and let it be. This is what's going on. You see. I'm not saying that's better or worse. Does it make sense?
So what you're saying
Yeah.
is it's an observational studies.
Mm-hmm.
Okay, I understand.
Yeah. You just count at the end. You know what happened, but okay, they like that. They like that. That's it. That's what I write. Like remember when we had those observations in class and the APs come in? Do they do anything? Do they influence the class? No, they're present there. Okay, and then they take their own notes. So what happens in the classroom, it's up to us, to you, me. But they don't say, hey, Miss Kindree, stop, do it better like that, or do it worse like that, or you see what I mean?
Mm-hmm.
Yeah, they don't tell you, hey, stop talking, hey, wake up, hey, do that, do the other. No, they just note what's going on, and that's it. That would be an observational study also, yeah? Okay. Yeah, well, that's one-on-one. Okay, one more example about whatever is left, and see how whatever is left plays now differently, okay, in our lives. Let's no, sorry, it's not them. I'm trying to get this here. Okay, I'm copying one more example, all right? And yeah, you'll have 6 questions on this quiz, 6 questions, so you'll just have to pick up observation, experiment, survey, observation, experiment, survey, whatever you think is closest to what's going on, okay? And keep reading all of them and so on and see how they differ, okay? So copy, I'm putting one more here. I hope it will get into here, otherwise we're not good. We'll make it to get in here. Okay. Do you see it? You see it, yeah, because it's big enough. Okay. Okay. Who is reading this one? Naija, do I hear you? Or Naija to the left? Who was talking? Sahar or Vanessa? Are you here, Vanessa? Oh, only John. John is with us. Okay, John. So
Okay.
what do you see here? How would this make it a survey, observational study, or experimental study? How is it different or alike? The above one.
Oh, I think this one's experimental because they're influencing what they do
Uh-huh.
in order to take the studies.
You see, and they want to see a link here. They want really to notice what's the difference and so on and so forth. So
Yeah.
so that's what's going on. They ask them to drink that, to eat that, you see. He's asking them to do something specific, you see, for a certain amount of time and so on. And that's how he concludes his study. Yeah, so they were not, the nutritionist didn't tell them, okay, guys, you eat what you want, you drink what you want, and I see you in the next 6 months, and, we see how you did. No, he gave them direct items to eat, and then he reconvened after 3 months, and they saw the results, yeah? Okay, so you're good? Good to go?
Yeah.
Good to
Yes.
go for 100, both of you? Jada, you were here, Okay.
I took the AKS 27 already, but
Mhm.
I think I can get 100 on AKS 8.
Of course, yeah, I'm sure about that. I'm really confident about that, yes. Any other questions about how things are going with the grades and so on?
No.
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 Oh, no.
No, we're good. Okay, just keep up with the class. You see, if you go over the announcements every day and go back, I mean, go for the earlier announcements, you'll see what's going on. And the DLD also has, I would say, complete instructions. So you're good to go. Any questions now? You are on Remind. Jada, Nichols, are you on Remind too?
Yes.
Okay, so please shoot an email over there, a text. You see, I mean, we communicate the best we can, yeah?
Okay.
Okay, enjoy this beautiful day. Get out in the sun a little, get your vitamin D, vitamin A, and vitamin E, okay? Do you hear me?
Yes.
Both of you,
Okay.
talk with your parents,
Yeah.
and have this replenished in your body every day. Immune system is our primary priority, okay? It's of most importance right now. And this is what you get your vitamin D from the sun outside, okay? Don't stay in the house. Get outside a little and go around the house. Do that garden, do that whatever you have around the house, and enjoy your time, even if it's a park close to you, whatever you think you enjoy, yeah?
Okay. Thank you.
Okay, I see you
All right.
next time. Next time. And please, Mama Mia's.
Visit our displays at Walmart stores in Texas, Arizona, Colorado, and Seattle.
But I wanted to tell you, join also the live sessions
right.
of the other teachers. Now you see those links with the days and times. Those are set, okay? Those are very set. You can always access them and join that teacher too. Okay. Have a good one. Ciao, ciao.
Okay, you too. Bye.
All right.
Bye.